district Moga. Today I will discuss about the topic biomolecule, in which I discuss carbohydrates, its classification, monosaccharides, its aldose and ketone, glucose and fructose, D and L conjugation, deuteration, anomers, and last is overthinking presentation. Let's start. First, we discuss about definition of biomolecule. A biomolecule is a compound found in living organisms. These include chemicals like carbon, hydrogen, oxygen, sulfur, phosphorus, and nitrogen. Biomolecules are the building blocks of life and play a very important role in living organisms. What are the four biomolecules? First, carbohydrates, lipids, third, nucleic acids, fourth is protein. Today, I will discuss about only the topic carbohydrates. Now, we will discuss about the definition of carbohydrates. Carbohydrates are large macromolecules consisting of carbon, hydrogen, and oxygen. Its general formula is CH2O, the whole one. In other words, we can say that carbohydrates are the hydrates of carbon. But this definition is not applied to all types of carbohydrates. Example, deoxyribose. Deoxyribose are carbohydrates, but this is not the hydrates of carbon. So, this old definition is not applied to all types of carbohydrate. So, next modern definition is carbohydrates are the optical active polyhydroxyaldehyde or polyhydroxyketose, or the compound that can be hydrolyzed into polyhydroxyaldehyde or polyhydroxyketose. This is the modern definition of carbohydrate. Next, we discuss about the Next, I will discuss about the classification of carbohydrate. Carbohydrates are two types, simple and complex. Simple are converted into two forms, monosaccharides and disaccharides. Complex is converted into polysaccharides. Let me discuss about the examples of monosaccharides are glucose, fructose, galactose. And example of disaccharides are maltose, lactose, sucrose. And the example of polysaccharides are starch, fiber, and glycogen. These are about the classification of carbohydrates. Now we discuss about the definition of monosaccharides, disaccharides, and last one is polysaccharides. Let's start. Now I will discuss about monosaccharides. First of all, I will discuss about definition. Monosaccharides are the simplest form of carbohydrates, which means they can't be hydrolyzed or broken down into smaller carbohydrates. Monosaccharides are the important molecules that complex carbohydrates are broken down into in order to generate energy. Its general formula is CH2O, the whole N, and N values lies from 3 to 7. Examples of monosaccharides are triose, tri means N value 3. Example is aldehyde, tetraose, in which N value 5, example ribose, hexose, in which n value equal to 6, example glucose. Next is heptose, in which n value equal to 7. These all about the monosaccharides. Next topic is disaccharides. Its definition is a disaccharides is a sugar formed when two monosaccharides are joined by glycosidic linkage. It's also called the double sugar. Like monosaccharides, disaccharides are soluble in water. Three common examples of disaccharides are sucrose, lactose, and maltose. In this slide, these are the two monosaccharides. These two monosaccharides are joined by glycosidic linkage, and this whole structure is called the disaccharides. Next topic is polysaccharides. Polysaccharides are the major class of biomolecules. They are long chain of carbohydrates molecules composed of several smaller monosaccharides. Means they are formed by the combination of large number of monosaccharides. These complex biomolecule functions are important source of energy in animal cell and form a structural component of plant cell. Next, discuss about characteristics of polysaccharides. First is they are not sweet in taste. Second, many are insoluble in water. Next, they are hydrophobic in nature. And last one is they are high molecular weight carbohydrates. This is all about the carbohydrates. Next topic is aldose and ketose. First, I will discuss aldose. Name indicates that aldose means being with aldehyde. In monosaccharides containing an aldehyde group are called aldose. It always present at one end of the carbon atom, that is at carbon 1 position. Example, glyceride. Second is ketose. Name indicates that saccharides which deal with ketone is called a ketose. It can be present anywhere along the carbon chain. Mostly it present at carbon 2. Examples, erythrose. In this slide, example shown that there is an aldehyde group which is present at carbon 1 position, means at terminal position. Second examples, there is a presence of ketone group which is present at carbon 1, 2. This is called a ketose. This is all about the aldose and ketose. Next topic is glucose. First, I will discuss about its source. It present in sweet fruits and honey. Grapes also contain glucose in large amount. Next, I will discuss about its preparation. There are two methods by which glucose can be prepared. First, from sucrose, and second is starch. When sucrose undergoes hydrolysis, means reaction with water, then they give two products. First is glucose and second is fructose. Similarly, when n molecule of starch undergo hydrolysis, means when they react with n molecule of under acidic condition, then they give glucose. This is the two method by which glucose can be prepared. Next topic is molecular reactions. Glucose can react with number of reagents. Now, next topic is chemical reactions. Glucose react with number of reagents. First reaction is reaction with HI. When glucose react with HI, then they give the product. Product is in the form of linear chain. Next, when glucose react with NH2OH, means reaction with hydroxylamine. Then they react with CHO group and give the product double bond NOH. Similarly, when glucose react with HCN, then cyanide group is attached, carbon number 1 position. These two reactions, that is hydroxylamine and HCN, give the presence of carbonyl group. Next reaction is when glucose react with bromine water. When glucose react with bromine water, then CHO group converted into COOH. This reaction shows that the presence of an aldehyde. Next, when glucose react with acetic anhydride, then they give the product. This product also show that there is a presence of OH group at different carbon atoms. Next reaction, when glucose undergo oxidation. When they undergo oxidation, then they give this product. This reaction again show that there is a presence of primary or poly group. This all about the chemical reaction of glucose. Next topic is fructose. Fructose is an important ketohexose. Means in fructose there is a presence of keto group. It is obtained along with glucose by the hydrolysis of sucrose. Fructose can be represented into two forms. First is linear form and second is cyclic form. I will discuss about in detail in next slide. Now, next is cyclic structure of fructose. Cyclic structure of fructose can be obtained with the help of linear chain. Linear chain can be converted into cyclic form under some condition. When they convert into cyclic form, then carbon number 2 join with carbon number 5 with the help of oxygen. And this is converted into cyclic form. In cyclic form, we observe that there are 5 membered rings. 1, 2, 3, 4, 5. So, we use the word furanose. When a cyclic ring is formed by 5 members, then we use the word furanose. This is all about the structure of fructose. Next topic is reducing and non-reducing sugar. Firstly, I am discussing about reducing sugar. Reducing sugar can reduce phthalate and tolerance agent. What is phthalate and tolerance? Phthalate is a two types, phthalate A and phthalate B. Phthalate A is a copper sulfate and phthalate B is a solution maltose, and lactose. This is all about reducing sugar. Next topic is non-reducing sugar. Non-reducing sugar is opposite of reducing sugar. In basic solution, non-reducing sugar is not reduced by tolerance agent and Fehling solution. Tolerance agent and Fehling solution are weak oxidizing agent. This is not reduced by non-reducing sugar. Next is there is no free aldehyde and ketonic group. Next property is they don't have an OH group attached to aromatic carbon, so they can't produce other compound. Examples of non-reducing sugar is sucrose and raffinose. This is all about non-reducing sugar. Next topic is D and L conjugation. D and L conjugation is deal with OH group and also deals with last chiral carbon of chain. If the carbohydrates has a hydroxyl group, means OH group, at the last chiral carbon toward the right side, it is denoted by letter D. If the hydroxyl group at the last chiral carbon lies toward the left side, it is denoted by letter L. This is shown in this slide that OH group on the right side, so we use word D. In this OH group on the left side, this is shown L. This is all about DL conjugation. Next topic is anomers. Anomers of glucose refer to isomers. Glucose has two anomers. Anomers deals with again OH group. Second, it deals with position of carbon 1. This one. This is the position of carbon 1 in this OH group. If OH group in the below side, then we use word alpha. If OH group on the above side, then we use beta. This is all about anomers. It deals with the position of hydroxyl group. Next is butyrylation. Firstly, we discuss about the definition of butyrylation. The spontaneous change in specific rotation of an optical active compound with time to an equilibrium value is called butyrylation. Let's discuss in detail. Butyrylation. Alpha and beta anomer of glucose are slowly changed into equilibrium mixture. In equilibrium mixture, both containing 36% of alpha D glucose and 64% of beta D glucose. This is evident from the fact that specific rotation of a freshly prepared aqueous solution of alpha D glucose falls from 112 degree to plus 52.5 degree with time, and beta D glucose increases from plus 18.7 to 52.5 degree. This is all about the butyrylation of glucose. Next topic is Haworth representation. Haworth representation is the three-dimensional representation of glucose, but they follow some rules. Let's discuss in details. Step to write Haworth representation. Firstly, that is hexagon 1, 2, 3, 4, 5, 6. This is hexagon, and oxygen is right on or placed in right side. Second step is the lower edge is thick to indicate that this edge is toward the observer. Means this line, lower portion is more dark, which means that they are placed toward the observer, and this portion is placed away from the observer. Next step are place all the rope which is present on left side in the structure above the plane of the ring. Means all the rope that are present in left side on the left side are present above, side, and all the rope which is present on the right side are below the plane of the ring. Like this, they are all the right side, and this is placed on the below side. And last rule is the terminal CH2O group is always placed above the plane of the ring. This is CH2 group. This is placed always above the plane of the ring. This is all about the forward representation. Next, MCQs. First MCQ is which of the following is the simplest form of carbohydrate? A. Carboxyl group. B. Aldehyde and ketone group. C. Alcohol and carboxyl group. D. Hydroxyl group and hydrogen group. Answer is B. Aldehyde and ketone group. Next MCQ question is which of the following monosaccharides is the majority found in human body? A. D-type. B. L-type. C. Alpha-type. D. None of these. Its answer is A. That is D-type. Next is which of the following is the most abundant molecule on Earth? A. Lipids. B. Protein. C. Carbohydrate. D. Nucleic acid. Its answer is C. Carbohydrates. Next MCQ is which of the following is the general formula of carbohydrate? A. C4H2O colon. B. C6H2O colon. C. CH2O colon. And last is D. C2H2O colon. COH2. Its answer is solution is C. That is CH2O colon. Next and last MCQ is which of the following is the simplest carbohydrate? A. Glucose. B. Glucose. C. Dihydroxy acetone. And last is D. Glyceride. Its answer is glyceride. That's all.